Hello, and welcome to the Schneider Electric Data Center Science Series. We are pleased to present our founder and Senior Vice President of Innovation, Neil Rasmussen, who will provide you with insight to the latest data center science research and emerging trends and technologies, as well as best practices on how to plan, design, build, and operate data centers. With decades of engineering experience and thought leadership, Neil has published over 50 white papers and holds 25 patents related to high-efficiency and high-density power and cooling infrastructure solutions. So here's Neil talking to you about specifying modularity for a data center architecture.
In the world of data center infrastructure, we hear a lot about the benefits of modularity. Some of the benefits are said to include faster deployment, lower cost, and higher reliability. Yet the definition of modularity remains vague, and it's difficult to compare the modularity of different data center designs. When we talk about the word modular, it's important to understand that every data center is made of modules. It's just a question of what is the level of granularity of those modules. A pump is a module, a wire is a module, but when we talk about a real modular data center, we're talking about systems where we've integrated a lot of these parts together into prefabricated, pre-engineered subsystems where the interfaces are well defined and we can essentially snap them together and deploy them in a much more predictable, scalable way. When we consider a particular data center project and agree that we'd like to specify the modularity of that project, the question arises, how do I actually articulate that specification, and how do I contrast alternative modularity approaches to a design? And can I have too much modularity, or might it be too expensive if I have too much modularity? These are very interesting questions and trade-offs that need to be addressed in a specific data center project. But in general, one of the most important things we can say about modularity is for those data centers where the upfront requirement in terms of power capacity are poorly known or they're likely to grow over time, the load is likely to grow over time, then it's much more valuable to have a more modular approach to the data center so we can deploy the data center infrastructure as and when needed to match a growing and changing IT load requirement. Modularity in data center architecture is clearly a trend that's evolving in the business, and we expect to see it evolve further in the next 5 to 10 years. We should expect that most data centers will be based on some form of system-level modules that snap together and whose interfaces are better defined. One of the most important benefits of that is, first of all, that we can move a lot of the manufacturing out of the environment of installation and back into factories. Another key advantage is that we can take the software and design it and code it ahead of time rather than trying to field code that software on a case-by-case basis on individual installations.
As this evolution towards increased modularity in data center architectures takes place, the benefits of standardized modularity will continue to accrue. Faster delivery times, lower costs, higher reliability, and perhaps most importantly, greater predictability of facility performance will all be realized. We believe these benefits are, in fact, possible today. The question then is how? How do I specify modularity for a project and do so in the right amount and in the right places? Neil has authored White Paper 160, Specification of Modular Data Center Architecture, specifically to answer these questions. This paper can be downloaded for free at whitepapers.apc.com.